In this problem, we're going to try to prove the following. We assume that f is a continuous function, and we want to prove or disprove the following. E raised to the integral of f of t dt between 0 and x minus 1 is bigger than the integral of f of t dt between 0 and x. Okay? Here we, from this, to define this function here, we assume that x is greater or equal than 0. Okay? We will see what happens if x is less than 0. Okay? So now we wanna, if we wanna prove this result here, okay? We wanna prove that it's true. To prove that this result is false, we can do the following. Okay, to prove that it's false, we need to find a function that's continuous such that e raised to this integral between 0 and x of f of t dt minus 1 is strictly less than the integral of f of t dt between 0 and x. Okay, to prove that this statement is false, find an f that would satisfy this inequality, strict inequality. Okay? So since f is continuous, this integral always exists. Okay? And we integrate between 0 and x is positive. Okay? So how to prove this result? The key to proving this result is that we know, and we have proven one of the relations about the exponential and the polynomial. We have proven that e to the power x is bigger than 1 plus x. Okay? With equality only when x is 0. Okay? So here, think of this x as the integral of f of t as being 1. Okay, when you integrate, you will get x here. Okay, take the 1 here, you will get e to x minus 1 bigger than x. And the integral of f of t dt when f of t is 1 is just x. Okay, so this statement is true for this function here. Is it true for f of t equals 0? Yes, because e to the power 0 is 1 minus 1 is 0, and 0 is greater or equal than 0. Okay? Here, this integral always exists if we assume that f is continuous. Okay? Therefore, if we change this variable here, we let it e to u minus 1 is bigger than u. Okay? And if we let u be the integral between 0 and x of f of t dt, then we have e to the integral of f of t dt between 0 and x minus 1 is bigger than the integral of f of t dt between 0 and x. Okay? Another key idea that we can use is we can use the fundamental theorem of calculus. Okay? Here, f is continuous. Okay? Therefore, we can differentiate. Okay? When we differentiate here, we will have f of x e to the integral f of t dt between 0 and x is bigger than, okay, f of x. But here, this proof is risky. Okay? And it's not accepted. We can start from here and go to this result. But we can't start from here and go here. Because if we have two functions, f is less than g, we don't have the f prime is less than g prime. We don't have that. Find such f and g. Always think of some easy functions. Okay, easy functions. Don't do any crazy functions, and use some easy intervals, like define the functions on this interval 0, 1, and let g of x be x, and let f be 1. So here, so let f be x and g be 1. So here we have x is less than 1. But once we integrate, we have 1 less than 0, which is false. This is an easy one to prove this result. So we can go from here to here. But using the fundamental theorem to get here is risky and it's false. Okay, anyways, so the quickest way to prove this result, and the standard way, is that use this result that I have proved using the mean value theorem. Okay, and let u be this integral, and plug it in here. Okay, and the result is clear now. Okay, if you see any errors, or you find a function f that would give me this result, please post it in the comment. I would be happy to see it. Thank you very much. If you see any errors or mistakes, please let me know. Thank you again.